Knowing what to range your rifle at in War of Rice is a skill that comes with experience, yet that knowledge is heavily influenced by what you were told in game. Like if your officer says to set your sights at 200 yards, or someone just simply advising his other peers based off this complexion. Worse yet, I have noticed many people underestimate the distances in the game by a large margin. But do not worry, because I seem to discover a way to know your range accurately enough to accurately range your gun. This all started when I had the idea of using the officer's binoculars as focus to estimate a distance. So what I did was hopped into a drill camp server, hit some targets at varying distances, marked them down, and then recorded the number of ticks of the binoculars needed to focus the targets at their respective distance. To avoid any convolution, here's the process I use regarding the ticks. My mouse is one where the wheel moves in discrete intervals, so moving to the first interval of the mouse registers one tick of the binoculars. I figured that it would be better to have the targets at the end of the focal distance than at the beginning. This was mainly because it was easier to tell when the target was at the beginning of a focal distance than at the end. So, when you want to find your own range, count the ticks starting at the first one and go until the target is in focus or just below, depending on the remaining distance, just how close you are to being in perfect focus. That wrapped up myself finding the data, and now on to the fun part. I hopped into Desmos and plotted my data as follows, the x variable being the number of ticks and the y being the range. It looks like the data shows quadratic behavior, and so I went down a rabbit hole of unnecessarily complicated extrapolation methods in order to pull a function out of this. Then I realized Desmos does this for you. Setting it to the power mode gives the best results, allowing more flexibility for the program. Once again, I had the idea to get even more accurate results. I figured anything above 100 yards would not need to be ranged, so I only used the data above that margin. This gave a lot more accurate results now within the tick. It seemed to be the best option for accuracy. However, the result was a bit too messy for quick and practical use, so I assumed the vertex to be 0, 0, and then averaged out all the slopes in order to get the most overall matching. I also calculated the error amount and plotted it for visualization for anyone curious. The actual error is the y value, and the x is the increase in distance. That does not mean you have to use the continuous approach, however. You can just look at the data. On flat ground, 16 ticks is about 200 yards, and 20 ticks is 400 yards, and etc. So there you have an easy way to find the range of your enemies. Assuming you're handy enough to have a calculator on you, simply use this formula for exact measurements, or the simplified version for speedy use yet some inaccuracy, and plug your amount of ticks into the x value, and the output should be the estimated range. Obviously, this is not the only way to find the range of your enemies, but it is the most versatile and probably fancy. You can always just have your men set their sights to whatever you think is good, and if they're actually hitting their targets, then you can be confident. You can also just memorize the map, I guess. But this experiment was fun, and I wonder if this would prove viable in actual games. If you'd like, you can let me know in the comments. Perhaps it can refine my data, because I know there are better sharpshooters than me who can hit 400 plus yard shots. But all that stuff is your homework, not mine. So I guess this politely leads to the end of this video. If there was anything I did not explain clearly to your consequence, or something that makes my method completely useless, like say this is something that directly tells you the range that I don't know about, let me know, and I'll surely clear things up. Who knows, maybe I can make a follow-up with new extensive data, but for now, a very fond farewell I bid to you all, officers and privates alike. And, as typically said, thank you all very much for watching.